In this video lesson for Math 12 students, we're going to explore Venn diagrams as they relate to set theory. Before we get into Venn diagrams, let's review some of the terms and notation we've already discussed. An element is one of the items or objects in a set, and we use this symbol for is an element of. A subset is a set within a set. All of its elements belong to a larger set, and its symbol looks like this. The universal set is the largest possible set under consideration. A subset might be part of a universal set. A complement is everything that isn't in the set we're considering. If we're talking about set X, its complement would be described as an X prime. And it turns out that if we add all of the numbers in a set and all of the numbers in its complement, we should get all of the numbers in the universal set. An empty set is just what it sounds like, one with nothing in it or no elements. We might see braces with nothing in between, or we might use this symbol for empty set. Lastly, we've discussed the disjoint. The disjoint is when there's no overlap between two sets, and that's going to be visually represented with some Venn diagrams. In this lesson, we're going to address the course expectation that Math 12 students will be able to read and create Venn diagrams to represent different sets, and we're going to practice connecting set notation with those Venn diagrams. A Venn diagram is one of the ways that we can visualize sets. Generally, the Venn diagram will include a rectangle to represent the universal set, and the label tells us that in this example, our universal set is the set of Canadian provinces, C. Let's consider those 10 provinces for a moment. Of the 10 provinces, some of the Canadian provinces are part of Atlantic Canada: Newfoundland, Nova Scotia, PEI, and New Brunswick. They can be placed within the subset. Some other Canadian provinces can be described as prairie provinces. Alberta, Saskatchewan, and Manitoba are all prairie provinces. Then we have some other provinces, British Columbia, Ontario, and Quebec, that don't fit either case. They're a part of the universal set, but not the subsets. We can see that these provinces are not part of the subsets because they're not included in the ovals that represent those subsets. In this case, we can also see that there is a disjoint. There is no overlap because visually, this set and this set do not overlap with each other. Now we can represent some of this information symbolically. We can say that the set of Atlantic provinces is a subset of the set of Canadian provinces. And likewise, the prairie provinces are a subset of the Canadian provinces. We could say something about how the Atlantic provinces are not a subset of the prairies, or vice versa. The prairies are not a subset of the Atlantic Canadian provinces. And we could start to do some counting as well. We can say that the number of elements in the set of Canadian provinces is 10, or the number of elements in the set of prairie provinces is 3. We can also talk about the complements. So if we discuss how there are 4 Atlantic provinces, there are going to be a total of 6 provinces which are not Atlantic provinces, and the not Atlantic provinces is that complement shown with the prime notation. Here are some of the important ideas to keep in mind after this first example. In a Venn diagram, each element can only appear once in the diagram, so we only saw Nova Scotia, or BC, written down once within the universal set. In a Venn diagram, elements that belong to more than one subset are shown in the region of overlap. We'll see this in a future example. We're also going to see that you can have more than 2 circles or ovals showing subsets in your diagram. And as we've already seen, a disjoint, remember when there is no overlap, is shown by not having any overlap or not having any elements within that overlap. And keep in mind, as we've discussed in class, a disjoint may also be referred to a situation where the subsets are mutually exclusive. Here's a pop culture example of a Venn diagram simply to show how these multiple overlaps can work. We have one circle representing pop culture figures with great power and great responsibility. Another circle representing pop culture figures who wear a red suit, and another one showing figures who know if you've been naughty or nice. So the creators of this diagram say that Spider-Man has great power and great responsibility within that set. Spider-Man also falls within the set of characters who wear a red suit, and so is in the overlap. Santa, by contrast, falls within the set with great power and great responsibility, wearing a red suit, and knowing if we've been naughty or nice. So Santa is in the overlap of 3 sets. Now let's look at an example we've already seen when we discussed set notation. We're going to consider the universal set of letters in the word mathematics. We'll call this set M for now. We're also going to create 2 subsets in this example, the set of vowels and the set of consonants. Let's begin placing the elements in our set. M is a consonant, A vowel, T is a consonant, H is a consonant, and so on. Since we've already used the letter M once, we won't bother to add a second one to our set. And here's our finished Venn diagram showing how all of these letters are elements of the set that belong in the word mathematics. We have a subset of vowels, a subset of consonants, and in this case, there's a disjoint. The overlap is empty. This is a case where our Venn diagram may have also looked sort of like this, with the 2 circles not overlapping at all to indicate that the vowels and consonants here show a disjoint, or we can say that they're mutually exclusive. This is a good time to practice some of our notation. We can talk about how the set of vowels is a subset of the letters in the word mathematics, and the set of consonants is a subset of the letters in the word mathematics. We can also talk about how the letter I is an element of the set of vowels, and again, we can use notation to do some counting. The total number of different letters in the universal set is 8. The number of vowels is 3, and so the number of not vowels, the complement, is 5. And notice that that's the same as the number of consonants. We can use all sorts of different examples here to practice with our notation. So now let's consider the universal set of digits. Within this set of digits, we're going to consider the subset of numbers that are even, numbers that are prime, and numbers that are perfect squares. When we start out considering 0, 0 is not prime. A perfect square is defined as having to be positive, and 0 isn't positive, so it doesn't fit that case. But 0 is an even number. When we consider 1, 1 is not even, it is not prime, but it can be considered a perfect square. 2 is both even and prime, so it appears in the overlap. 3 is a prime number. 4 is a perfect square and even. It will appear in the region of overlap. 5 is a prime number. 6 even. 7 prime. 8 even. And 9 a perfect square but not prime. This Venn diagram allows us to see that there is no overlap between the prime numbers and perfect squares. It allows us to identify numbers that are even and fit one of the other descriptors, and allows us to see all of the elements that are part of the universal set of digits. This would be a great example of a question we might have to represent symbolically later on down the road. We discuss Venn diagrams in Math 12 because we're going to use them in a future class to help us with questions about and or. In this case, the Venn diagram shows us that altogether, there are a total of 4 sisters. And 2 of these sisters fit within the category of being blonde. The diagram also shows us we have a total of 3 of these sisters with green eyes. But wait a minute, that gives us 5 sisters altogether when the universal set only has 4. How did we get a total of 5 by adding these? Well, it turns out we have to consider that one of those 2 blondes has green eyes, and one of those 3 green eyes is also a blonde. We'll discuss this more in a future class, but this gives us some context for why we discuss Venn diagrams. As we practice working with Venn diagrams, our goal is to be able to answer a question like this. In this question, we are told that we have 25 people surveyed. That's going to represent our universal set. We're also told that of these people who are surveyed, 14 own an Xbox, 12 own a PlayStation, and 7 are in that region of overlap, or people who own both. That 7 now will be included within the 14. So there will be 7 people who own an Xbox and a PlayStation, and 7 people who just own the Xbox. The overlap is also included in these 12 who own their PlayStation, 7 who have both, and 5 extra. This will allow us to answer the question about how many people don't own a gaming console. Altogether right now, we have 7 and 7 and 5, or 19 people falling within one of the subsets. That means there must be 6 people who didn't own any consoles whatsoever. How many people do not own a gaming console? Based on our Venn diagram, 6. This is the kind of question we'll aim to answer by the end of this unit. For now, our goal is to be able to read and represent information in Venn diagrams and connect this to the work that we've been doing with the symbolic notation. This is a good time to double check your notes, see if there's anything else that you need to ask or to watch again, and now to complete some practice.